Hi guys, let's look at the homework questions of exercise 5C, which I had given in the video. Okay, so this exercise is basically about the difference of two square. So I noticed that the first term can be written as 5 times 2a minus b the whole square, and 81b square can be written as 9b the whole square. Let's open the bracket. This is 10a minus 5b the whole square, and this is 9b whole square. So what we have is x square minus y square, which means x, in this case 10a minus y 5b plus 9b multiplied with 10a minus 5b minus 9b. Yes, x plus y, x minus y. I notice 5b and 9b can be added, so this is 10a plus 4b multiplied with 10a minus 14b. Between these two terms 2 is common, between these two terms 2 is all common again. So let's take out 2 from here. This is 5a plus 2b. Let's take out 2 from here. This is 5a minus 7b. So 2 into 2, 4. 4 times 5a plus 2b multiplied with 5a minus 7b. That's the final answer. You would write this as 25 times 2a minus b the whole square minus 81b square. Right. So that's the way to represent your final answer. Done. Let's move on to the next question. The next question that we do is question number 6. 4a square b minus 9b cube. I notice b is common between these both terms. Let's take b common. What we are left with is 4a square minus 9b square. 4a square is nothing but 2a the whole square, and 9b square is 3b the whole square. So b times 2a plus 3b multiplied with 2a minus 3b. This is equal to 4a square b minus 9b cube. That's the final answer. Good, let's move on to the next question. The next question that we have is question number 11. It says a plus b whole cube minus a minus b. So this is a plus b the whole cube minus, if I take negative 1 common, what I am left with is a plus b inside the bracket. So now between these two terms, a plus b is common. So let's take a plus b common. What we have left from the first term is a plus b to the power 2. Yes, there was power 3, 1 has been taken common, and this is minus 1, which is nothing but 1 square. So now inside the bracket I have x square minus y square. So a plus b remains common, and what we have is a plus b plus 1 multiplied with a plus b minus 1. And this is equal to a plus b whole cube minus a minus b. That's the final way of representing your answer. That brings me the next question. Next question that we do is question number 14. It says 4a square minus 49b square plus 2a minus 7b. I notice this is 2a whole square, this is 7b whole square, and 2a and 7b is already here. So this can be written as 2a whole square minus 7b whole square plus 1 times 2a minus 7b. This is x square minus y square, which means 2a plus 7b multiplied with 2a minus 7b. And the second term now is 1 times 2a minus 7b. 2a minus 7b is common between these two terms. So let's take 2a minus 7b common. What we are left with is 2a plus 7b from the first term and plus 1 from the second term. That's the final answer. You would represent it in the form of the final answer. I am not writing it anymore for any of the questions in this video. But from the exam perspective, you would need to write it as the question. So the factorization of this, so your answer would look like something like this is equal to 2a minus 7b multiplied with 2a plus 7b plus 1. That's the final step which should be there in your answer sheet. Next, this is 4xy, negative x squared and negative 4y squared. I notice if I take these three common, well, I think this will be something of the form x and 2y whole square, and this is z square, right? So let's see what do I get. But this is plus z square, so maybe I should take negative 1 common for all of them. What we'll get will be x square plus 4y square minus 4xy minus z square. What I've done is I've taken negative 1 common for all these four things. So all the signs change. So negative x square becomes plus x square, negative 4y square becomes plus 4y square, plus 4xy becomes negative 4xy, and plus z square becomes negative z square. The first three terms inside the bracket is nothing but x plus 2y the whole square. No, not x plus 2y, x minus 2y the whole square. So let's just write this down. This is x minus 2y the whole square. Yes, that's correct. And this is z square. Now we have the form a square minus b square, which means x minus 2y plus z multiplied with x minus 2y minus z. That's the final answer. In case you don't want to keep the negative 1 outside, let's multiply with which one do you want to multiply? Let's multiply it with this bracket. So the first bracket remains x minus 2y plus z, and the second bracket becomes negative x plus 2y plus z. That's also correct because it's exactly the same answer as the first one. In case you don't want to write the first term as negative, then we can also write this as z plus x minus 2y and z minus x plus 2y. Right. So z plus x minus 2y and z minus x plus 2y. Perfect. That brings me to the next homework question. The next homework question was question number 18. Question 18 says a square plus b square minus c square minus d square. Oh, there is a 2ab and there is a square plus b square. There is c square and d square and there is 2cd. So let's group it the way I've underlined. What we have is a square plus b square plus 2ab. Group it together and minus. Let's take minus common. What we'll be left with is c square plus d square plus 2cd. The first three terms basically are a plus b the whole square, and the next three terms is nothing but c plus d the whole square. Now this is of the form x square minus y square, which means x in this case a plus b plus y in this case c plus d multiplied with again x, which is a plus b minus y in this case c plus d. Let's open the small brackets inside the big one, which is a plus b plus c plus d multiplied with a plus b minus c minus d. That's the final answer. Nothing else can be factorized. It can't be factorized any further. So this is how you would represent your final answer. A plus b plus c plus d, a plus b minus c minus d. Now that's how you would represent your final answer in the answer sheet. Good. Let's move on to the next one. The next one is question number 19. 4x square minus 12ax minus y square minus z square minus 2yz. These three terms basically look like y plus z whole square or y minus z whole square. Let's see. And this is 2x the whole square. This is 3a the whole square. So let's group these three terms together and see what we get. So 4x square plus 9a square minus 12ax minus, let's take negative common. What we have is y square plus z square plus 2yz. So this is nothing but y plus z the whole square. That's very simple. Let's see what is this. This is 2x whole square. This is 3a whole square. And this is negative of 2 times 2x into 3a. Yes, so this first three terms are nothing but 2x minus 3a the whole square. Yes, 2x minus 3 whole square, and this is y plus z the whole square. Again, difference of two squares. So first term plus second term multiplied with first term minus second term. Let's open the small brackets. What we have is 2x minus 3a plus y plus z multiplied with 2x minus 3a minus y minus z. Right, nothing else can be factorized. So let's move on to the next one. The next one that we're doing is question number 23. It says x square plus 4y square minus 9z square the whole square minus 16x square y square. So this is first term square, and see if I can write this as something. So this is x square plus 4y square minus 9z square the whole square, and the second term can be written as negative 4xy the whole square. Yes, that's negative 16x square y square. So this is a square minus b square, which means first term, which is x square plus 4y square, not plus, minus 9z square plus 4xy multiplied with x square plus 4y square minus 9z square minus 4xy. Now I notice if I look at these three terms which I have underlined, this is x plus 2y the whole square. And these three terms that I have underlined in the second bracket is x minus 2y the whole square. So let's write it this way. This is x plus 2y the whole square minus 9z square is nothing but 3z the whole square. So that's our first big bracket. And in this one, we have x minus 2y the whole square minus 3z the whole square. Now this is a square minus b square. This also is a square minus b square. So x plus 2y plus 3z multiplied with x plus 2y minus 3z. That's the first big bracket. In the second bracket, we have x minus 2y plus 3z multiplied with x minus 2y minus 3z. Done. There's nothing else which can be factorized. So that's my final answer. Again, in the exam, you would represent it properly with the question as well. Good. You could put a star to this question. Interesting one because it required us to factorize 2 times. Next one, question number 25. A square minus b square and a plus b the whole square. Okay, so the first two terms can be factorized as a plus b multiplied with a minus b, and the second term is a plus b the whole square. Now I have a plus b common in these two terms, so if I take a plus b common, what remains from the first term is a minus b, and what remains from the second term is a plus b. Let's reconfirm. If I take a plus b out, what remains is a minus b, and what remains is 1 a plus b. Perfect. Let's open this bracket. This is a plus b multiplied with a minus b minus a minus b. Negative a and positive a get cancelled. So what we have is negative 2b multiplied with a plus b. That's the final answer. Good. Let's look at the last couple of homework questions, which is question number 28. Question 28 says 4x square plus 1 upon 4x square plus 1. This is clearly 2x plus 1 upon 2x the whole square. Let's see how I can manage it. So the 2x plus 2x whole square would be 4x square. The second term square, that's 1 upon 4x square plus 2 times 2x multiplied with 1 upon 2x, which means I need a 2 here, right? But I have only 1. So if I need a 2, what should I do? Yes, I could add a 1 and I could subtract a 1, right? I have added 1, I have subtracted 1, which means I haven't changed the expression. But what this has helped me do is the first 4 terms will become 2x plus 1 upon 2x whole square, and this obviously is negative 1 the whole square. So this is 2x plus 1 upon 2x the whole square minus 1 square. Now this is of the form a square minus b square, which means a in this case 2x plus 1 upon 2x plus b in this case 1 and 2x plus 1 upon 2x minus 1. That's the final answer. I can't factorize it any further. Again, you can put a star because this question required us to add and subtract an element on our own. That brings me to the last homework question. Let's see what we can get. I noticed that these three terms would make a quadratic, and this is nothing but 2x square the whole square. So what we have is 2x square the whole square, and this would be x square plus 12x plus 36. This is x plus 6 the whole square. That's correct. So this is 2x square the whole square, and this is x plus 6 the whole square. Now this is the form a square minus b square, which means 2x square plus x plus 6 multiplied with 2x square minus x plus 6. Let's open the bracket. 2x square plus x plus 6 multiplied with 2x square minus x minus 6. Let's see if I can factorize the quadratic expressions. So if a quadratic expression is factorizable, then b square minus 4ac is a perfect square. I hope you remember this from the previous exercise. So let's look at, in this case, 2x square plus x plus 6. A is equal to 2, b is equal to 1, c is equal to 6. b square minus 4ac would be 1 minus 4 into 2 into 6, which is 1 minus 48. No, this cannot be factorized, so we would leave this first expression as is. Let's look at for the second expression. I need to find factors of negative 12, the sum of which should be negative 1. Yeah, we've done this enough number of times. That's negative 4 and positive 3. So 2x squared minus 4x plus 3x minus 6. All I have done is I have broken up negative x as negative 4x plus 3x. Grouping it the way I have underlined, the first term remains the same, 2x squared plus x plus 6, and here I get 2x common. What we get is x minus 2, x minus 2. In this case, 3 common, x minus 2. What we have is 2x squared plus x plus 6, and this is x minus 2 times 2x plus 3. Again, a very interesting question. It had a combination of difference of two squares and then quadratic as well. Thank you so much. Take care. Be safe. I hope you like the video. If you have any questions or queries, please feel free to write into me. Bye-bye.